Welcome to episode 439 of AI Brief. I am Amin.
And I am Leah.
If you've looked at the pace of scientific discovery lately and thought we are living in a sci-fi novel, you will definitely want to pull up a chair for this one. Today's main points cover a massive blurring of the lines between biology, artificial intelligence, and physical science. We are talking about an AI that proactively reads your cognitive state, living brain cells that play video games, human beings farming in simulated moon dirt, and major updates in planetary defense and hypersonic drones.
It really is a wild lineup today. The goal is to synthesize all these rapid advancements and figure out exactly what they mean for the future of human capability. More importantly, we are looking at how our very interaction with technology is shifting on a foundational level.
And we are going to break it all down so it's entirely digestible. Let's jump right into today's new updates. The major breakthrough today comes out of the MIT Media Lab. They just unveiled a system called NeuroSkill. Think about the typical AI agents you and I interact with every single day. They just sit there. They are passive, waiting for you to type out a prompt or speak a command. NeuroSkill flips that whole script by connecting directly to wearable brain-computer interfaces to proactively understand what you are feeling.
These are consumer-grade wearables like a Muse headband or an OpenBCI setup. To grasp how this works, we need to look at the underlying architecture they built. NeuroSkill relies on what is called an EXG foundation model. For those not deep in the biometric weeds, EXG is just a catch-all term for measuring electrophysiological signals.
So we are talking about tracking brain activity, muscle signals, heart rate, all of it simultaneously.
Exactly, and when the system takes those continuous biological signals and combines them with sophisticated text embeddings, it creates a real-time digital map of your mental state. It effectively translates that raw biological data into a language the AI can understand, granting it a baseline level of cognitive awareness regarding the user.
This proactive engagement feature is where this goes from a cool lab experiment to something that could change how we work. Instead of waiting for you to get frustrated and ask for help, the AI senses your biological markers. It knows when you're confused, it detects the physical signatures of stress or intense focus, and then it just intervenes.
The MIT researchers are calling these autonomous interventions tool calls. Picture sitting at your desk trying to process a really dense spreadsheet. Your muscle tension spikes and your brain waves show mounting cognitive load. NeuroSkill registers that frustration. Without you doing a single thing, it might automatically dim the room lights to reduce sensory input, or maybe pop a helpful summary tip right onto your screen.
They manage this whole flow through a custom harness called the NeuroLoop. It creates this seamless, continuous cycle between your physical state and the AI's response. The developers coined a term for it, agentic empathy. The AI stops being a tool you wield and becomes an active agent responding to your reality.
It is also incredibly efficient by design. They released this in March 2026 as GPL-v3 open source software, and crucially, the system runs fully offline on the edge. It processes directly on your specific hardware, like your laptop or phone, meaning your biological metrics never have to travel to a remote server.
Which removes the traditional bottleneck we have dealt with since the dawn of computers. You no longer have to compress a nuanced thought into clunky keystrokes.
Yeah.
But speaking of blending biology and tech, this carries right over into our next source. We're moving from AI reading our biology to biology actually acting as the AI.
The Cortical Labs biotech experiment. They took a petri dish filled with living, lab-grown human brain cells and literally taught those cells to play the 1993 video game Doom on a microchip.
I was reading the notes on this and my jaw hit the floor. They are calling it the world's first code-deployable biological computer. How do living cells even see a video game interface?
The scientists translated the visual interface of Doom into precise electrical signals. They fed those pulses directly into the neural network resting on the microchip. Because neurons naturally seek predictable environments, the scientists were able to create a sophisticated feedback loop.
So when the cells navigated the game successfully and hit a target, they received a predictable, organized electrical pulse as a reward. But when they missed, they received random, chaotic electrical noise.
And the living neurons naturally rewired themselves to avoid the chaotic noise. They actively learned how to navigate the game and target enemies in real time. The reason this is so monumental comes down to energy efficiency. A human brain operates on roughly 20 watts of power, while massive AI server farms require gigawatts.
By demonstrating that organic human cells can process complex digital inputs and produce successful outputs, we are looking at the foundation for biological processors that could power hybrid computers at a fraction of today's energy costs. Now, let us shift our focus to everything else in AI today. As we examine the integration of advanced systems in harsh environments, our scope must extend significantly beyond our own planet. Scientists from UT Austin and Texas A&M have recently achieved an unprecedented milestone in space agriculture.
They have successfully cultivated and harvested chickpeas in simulated lunar regolith. To fully appreciate the magnitude of this accomplishment, we must recognize the notoriously hostile nature of moonbird. It is essentially composed of crushed glass and rock, and it is completely devoid of the organic matter and microbial life that earthly plants require to extract nutrients.
Furthermore, it is a highly toxic medium, heavily contaminated with dangerous heavy metals, making it an incredibly unforgiving environment for biological growth of any kind.
Which is precisely why the metric they achieved is so significant. The researchers discovered that experimental mixtures containing up to 75% simulated lunar regolith could still yield a successful harvestable crop. Consequently, future astronauts would not need to transport massive quantities of Earth soil, fundamentally altering the logistics of long-term Artemis missions.
Naturally, the scientific community must now address the practical next steps. Researchers must rigorously test these space-grown crops to ensure they are safe for human consumption, verifying that the plants did not absorb the toxic heavy metals, while also confirming they possess the necessary caloric and nutritional density for sustained lunar deployment.
This rapid advancement in our relationship with the cosmos is also reflected in the field of planetary defense. We have recently received exceptionally precise new data regarding the 2022 NASA DART mission, during which a spacecraft intentionally impacted the asteroid Dimorphos.
The initial mission was celebrated globally because the kinetic impact successfully shortened the asteroid's orbit by 32 minutes. However, the newly analyzed measurements confirm that the impact achieved something far more profound than simply altering its orbit around its twin asteroid.
The data confirms that the impact actually shifted the trajectory of the entire asteroid pair around the Sun. While the physical alteration in that solar trajectory was minute, mathematically it doubled the overall deflection effect of the initial strike. This provides humanity with our most compelling, tangible evidence to date that we possess the physical capability to redirect a hazardous asteroid before it impacts Earth.
Parallel to these extraterrestrial defense strategies, we're witnessing rapid developments in defensive aerospace capabilities within our own atmosphere. The Atlanta-based aerospace startup Hermeus has successfully completed a test flight of their Quarter-Horse Mark 2.1 prototype drone.
The Quarter-Horse program represents a systematic and rigorous testing campaign explicitly aimed at breaking the sound barrier utilizing fully autonomous systems. Although this recent flight remained subsonic, validating this data will propel their subsequent iteration directly towards supersonic flight testing.
Ultimately, these tests are paving the way for Dark Horse, which is slated to be a fully reusable hypersonic aircraft engineered for advanced defense missions. Combining autonomous aerial systems with speeds exceeding Mach 5 will fundamentally transform the global defense landscape.
The sheer engineering required to maintain structural integrity and navigate autonomously at those velocities is staggering. Now, transition to our final content segment, let's look at today's trending AI tools. The landscape is moving incredibly fast, and there's several models dominating the conversation that you should have on your radar.
First on the list is GPT-5.4. This iteration is heavily focused on advanced multimodal reasoning, and researchers are using it extensively to synthesize massive datasets and complex academic papers in real time. Then we have Aident AI Beta 2, which operates as an autonomous web agent. You essentially give it a high-level goal, like researching a market trends and compiling a spreadsheet, and it takes over your browser to execute all the necessary clicks and navigation independently.
Next up is GojiberryAI. This tool is carving out a huge space in e-commerce right now. Brands are using it to automate their customer feedback analysis and dynamically generate highly personalized post-purchase surveys based on user sentiment. We are also seeing a lot of chatter around Qwen3.5 Small. Its primary advantage is on-device edge computing. It is lightweight enough to run advanced reasoning tasks locally on mobile phones without requiring any cloud connection.
Which is perfect for privacy and offline functionality. Game developers are also flocking to a new tool called Deep Personality. They're using it to power non-playable characters, giving NPCs dynamic memories and complex emotional states that permanently evolve based on how the player interacts with them. Then there is Gemini 3.1 Flash-Lite. Google optimized this specifically for high-speed, low-latency mobile processing, allowing smartphones to handle complex voice and vision tasks with virtually zero lag.
We also have nothing here trending. It is a highly specialized audio processing tool being used in broadcasting to instantly isolate and remove complex, unpredictable background noise from chaotic live recordings. And finally, Enia Code is gaining massive traction among software engineers. It is an AI coding assistant specifically trained for legacy code migration, automatically translating decades-old programming languages into modern, secure frameworks. Synthesizing the immense scope of today's deep dive, it is striking to look at the profound duality in our current scientific progress. Think about the ground we covered. On one hand, humanity is turning deeply inward. We are mapping our own biological brainwaves to give artificial intelligence proactive empathy, and we are harnessing the literal computational power of lab-grown brain cells.
And at the exact same time, we are reaching further outward than ever before. We are engineering ways to grow food in the toxic regolith of the moon and physically altering the solar trajectories of massive asteroids. It is the micro and the macro advancing simultaneously at light speed.
It leaves us with a provocative thought to mull over. If AI can now be engineered to directly sense our cognitive burnout, and biological brain cells can be trained to actively process digital environments, at what point does the boundary between a biological brain and an artificial processor completely dissolve? And if that happens, how will that change our very definition of what it means to be alive?
That is the defining question as these technologies merge. Keep questioning those fundamental assumptions and stay curious.
Thank you for joining us. Please be sure to follow and share the podcast if you enjoyed the discussion. See you in the next episode.